Welcome back to Summarize Science. Teaching a robot a new skill is incredibly difficult, often requiring hours of complex programming or direct control. But what if we could just show a robot what to do, the same way we'd show another person? The problem is, humans and robots are built very differently. Our movements don't always translate. Simply trying to make a robot copy a human's hand motion can lead to physically impossible or clumsy actions, which can actually make the robot perform worse. This is the core challenge tackled by researchers at Cornell University in a paper called X-DIFFUSION. Their key idea is both clever and counterintuitive. They make the human demonstrations less clear to make them more useful for the robot. They do this using a technique related to diffusion models, the same kind of AI that generates images from text. Imagine taking a video of a human action and gradually adding digital noise or static, making it blurrier and blurrier. As more noise is added, the tiny, specific details of how the human moved, like the exact way they gripped an object, fade away. What's left is the high-level goal of the action, like move hand toward the pan. This is where the magic happens. The researchers trained a separate AI to act as a judge or a classifier. This classifier's only job is to look at a noisy, blurry action and guess whether it was originally performed by a human or a robot. The robot's training policy then follows a simple rule. It only learns from a human's noisy action if the classifier is fooled into thinking it could have been a robot's action. If a human action is very similar to how a robot would do it, it's useful for training even when it's only a little bit blurry. But if an action is very different and impossible for the robot, it's only used for training when it's so blurry that the original human-specific movements are completely gone. This way, the robot learns the overall strategy without trying to copy motions that would break it. So, does it work? The results are impressive. Across 5 different manipulation tasks, like closing a drawer and serving an egg, the X-Diffusion method consistently outperformed all the other approaches. It achieved a 16% higher average success rate than the next best method, which is a significant improvement in the world of robotics. You can see here that naive approaches that just copy humans sometimes perform even worse than a robot that only learned from a few of its own demonstrations. So, let's recap the breakthrough here. The X-Diffusion framework allows robots to learn from large, diverse sets of human videos by intelligently filtering the information. It uses noise to blur out the low-level, embodiment-specific details while preserving the high-level task goal. This means we can finally start to leverage the massive amount of human video data all over the internet to teach robots. This could dramatically speed up how we train robots, making them more versatile and capable of performing a vast array of tasks in the real world, all from just watching us. Thanks for watching Summarize Science.